So,
Good morning.
mm, so yeah, in the last session, we talked about like how to perform data combination by using what? Joiner transformation, right? So where we explored different options, like different ways to combine this particular source system data, right? Yeah. So yes, we covered different options. Now the question, let us say we need to combine the data from more than two sources. In that case, how do you do it? There's a question, right? So to answer that, so first joiner would take responsibility of first two source systems, and output of this will be taken as input to what? Another source, and then again apply one more joiner. So that is why joiner is basically, it's also one of the expensive transformation. Yeah. So yes, joiner, aggregator, the two most expensive transformations in any integration tools. Yeah. But sorter is also there, but they aggregate is much more than join is also much more than sorter transformation, because they do sorting then followed by either join or aggregation. Yeah. Fine. So let me try to bring up this. Yeah. So today we are going to talk about another combinable transformation, which we call lookup. Yeah. I think we didn't talk about it, right? Only we know the Navi.
Yeah, we did not, yes.
No,
Yes.
we haven't talked about it. Yes.
Yeah. So yeah, let us try to talk about lookup. Yeah. So as the name suggests, look, in the sense search. Yeah. In the sense search based on what? Key. And what do you expect? Yeah. That's it. It's as simple as that. Which means for a given key, we expect what? Corresponding value. So why? Because this is purely driven from the business. For example, for today's business, customer would expect the data from India. From tomorrow's business, US. Day after, Canada. Some other day, Germany, whatever. So which means, depending upon the business expectation, we can have corresponding what I call country data, where you will have country code followed by country name. Similarly, country code followed by the country name, whatever, right? So this name we can obtain it from this particular lookup, yeah? Which means lookup maintains key value pairs. Yeah? But source will have only, let's say, country code, then corresponding value will be pulled out from the lookup. Simple concept. Yeah? So yes, to do that, there are many options or many ways to do that. One by using what we call connected, other by using unconnected. Yeah? So what is a connected, unconnected means? So connected, as the name suggests, we use what pipeline or link line with arrow, which is a link or a pipe. Yeah? So which means data transfer would take place from predecessor to the lookup through pipelining is what we call connected. Yeah. So meaning, let us say we have source and you will have lookup. So which means this line with arrow you can say, right, through which data transfer will take place. So this is where we use the term pipelining or connected or link or virtual data set. These are all synonyms. Yeah. So that's ultimately data transfer will take place through pipeline. Once the source data gets matched with the lookup table, data would get transferred to a target. So whatever we do lookup, can we compare this particular lookup with any one type of join? Is it going to be inner join, left outer join, right outer join, or full outer join? Answer is what? Answer is left outer join. Meaning you will get matching records plus you would also get all unmatched records from left table, which is source. In this case, it guarantees that we don't lose any source data. That's what is the intention of this particular lookup. That is why by default, anyway, lookup supports left outer join. Yeah. Yeah. Now let us try to log in. And another one or another type of lookup is what unconnected. It's not a type actually. So connected can be lookup can be used through pipelining or with no pipelining. That's what is the categorization. Yeah. So which means no pipelining means no link. That's what it means. Yeah. We will see. So let us try to configure. Yes. So this is a source. Let us say in order to perform join, right? What we did, we have used SEQ1 and SEQ2. In this case also, we use what, let us say SEQ1 as a source or source link or primary link, yeah? And SEQ2 is going to be the reference link or lookup link or secondary link or foreign link. There are synonyms. Remember this. Yeah? So, which means we can use source data and reference data. And source data would compare with the reference data. If it matches, now how the lookup works? So matching records plus unmatched ones, both will be transferred to a target. But matching data, you'll have both source data plus lookup data. For unmatched, only source data. And minus lookup data would contain either 0 or null or empty. I think we talked about left outer join, how it works yesterday, right? So same concept holds good here. Yeah. So now let us try to take out all the links and try to get the lookup transformation. Yes. Yeah. Yes. So now let's do configuration. First is a source. Yes. Yeah, SQ1 we have already given it. Fine. That's the first thing. And then look up. Yeah. Now we have just given SQ2 here. Yeah. So far so good. Now let us try to connect. This is what we call pipelining. Right? That's it. Yeah. Let's also configure target. Yeah. Yes. Now let us talk about from the syntax perspective what need to be considered. So remember, join what we did, you have just built a condition. Yeah. Like left table dot column equal to right table dot column. Same concept here also. Yeah. So which means we apply condition here also. So source one dot column equal to lookup dot column. Yeah. So which means we build a condition. Prior to that, we would also take one of the column as the column or input column that we use for comparison. Which column we are using here? C1, right? Next, we would also expect the return value from the lookup. Yeah. If you don't specify anything, all the columns will be returned. If you specify, you can also return only specific thing. For example, let's say C2. So C1 is going to be, let's say, input, and C2 is going to be the return value. That's it. So which means for a given key, which is C1, you will see what the corresponding value, which is C2. That's it. So this is what we do as part of this particular lookup. Let us see how to configure. This is exactly similar to joiner. Yeah. But difference, I'll talk about it, where it differs. There are many factors, like are we going to deal with a small or big data? If small data, which is preferable, big data, which is preferable, or mid-sized volume of data, which is preferable. These are all questions. So we'll answer those questions one by one. Yeah, fine. So now let us understand how to configure this. So we have lookup object, we have already specified that. Then lookup condition. Can you see here? There is a conflict because we have got similar column names. Let us resolve that conflict. Let's say S1 underscore. Or see, this is similar to what we did as part of journal, right? Click on plus and specify C1 equal to C2. Now the question, can you see here? I think I would have said it yesterday. It can support any relational operator. Yeah? So it's not mandatory that we should use only what? Equality operator. So we can also use less than, greater than, or whatever. Yeah. So that's one extra thing we have as part of lookup. Yeah. Now, return fields can specify one, and if you don't specify, all will be returned. Yeah. So which means for a given key C1, we expect value C2. Yeah. Or we can also specify all also. Yeah. So if you want more than one column, right, you can also expect that. Yeah. Anyway, this scenario we have it, we don't have to specify. So that's it. And this we configured. Incoming fields we do. See here, these are the source columns, right? Yeah. Lookup columns, anyway, we know it. Yeah. And field rules, I think I already talked about it, right? So if you want to limit the fields based on what include, exclude, all that, I think we talked about it. Okay. So that's it. Simple. Select the key column. Second, build a condition. Third, return value. That's all about lookup. Now let us talk about mapping, and let's go to lookup connected. This is the name of the mapping. Yeah, any questions so far? Ready? And B, Ali, and Vinod.
Can you hear me?
Yes, sir. Ali, you can hear me, right?
Yeah. So let's suppose if the lookup contains more than one record, and we want to get the maximum value from the lookup, because if it's going to return two rows for each source record, then we might get into the duplication issue.
Right. Yes. Yeah, go ahead.
So how do we tackle that? So we want to get the maximum value from the lookup
Yeah.
for the
Can you
key.
see here? Multiple matches. So return first row, last row, any row, all the rows. So we can select one of these options. These are the supported options. Ali. So which means
Okay.
any row means it can return either first or last. If you want only first matching one, you'll get to see only first one. Ali. Last means last. Any means it will take a call. Yeah. So all means you'll get
Okay.
duplicates, like I just said. So you got all the provisions. It's up to us to take a call, like what to choose. Yeah.
Okay.
Yeah. Fine. So yeah, I think we executed, right? That's completed 5 rows, right? Because source has got 5 rows. All the rows you will get it. That's why, as part of the definition, I was trying to talk about you'll get matching plus unmatched. Somewhere I mentioned that. Yeah, this one. But matching means you'll get lookup value. Unmatched means lookup value would contain either zero, null, or empty. That's all. Nothing else. Which is equal to left outer join. Right? Yeah. Now can you see if you look at the matrix, source 5, target 5. We have not missed any records, right? Now let's look at the result. This one, right? Yeah. We got all 5 rows. Yeah. So wherever there is a match, you will see all. Wherever there is no match, you would see lookup value. So where do we have lookup value here? C1, C2, C3. It's empty, right? Yes or no? So here 1, 1, here 4, here 7, nothing got matched up. Let's see. I think some matches will be there. On one there is a match. What is the condition here? See, okay, this is a problem. Can you see? We made a mistake here. So that is why there's no match. So we got all the records where there is no match because we gave wrong condition. That's fine. We understood, right? If none of the records have got matched, right, then result will be all the rows. But right table data, which is lookup data, will be either empty or zero, whatever. So you can see empty data right here for all the columns. So all the columns from the lookup. Clear, no? This is the first one. Now let us see. We have given the right condition now. Now we should get matching ones plus unmatched ones. So let's refresh this. See, still I've got all the 5 rows, but you will see difference in results. Yeah. Can you see 1 4? There is a match 1 1 4 4, right? And also 1 here. So you will see matching records. Yeah. So can you see here, Ali, to answer your question, right? It is returning what? First row. Yeah. So 1 2 3 1 2 3. If you look at the SEQ2 data, yeah, see here 1 2 3 1 2 3. First row you could able to see here. If you have one more row where there is a 1, then you will get clarity which one is going to pick up first or last, whatever, right? So that's return any row or first or last row. We have options to be select. Yes. So that's it. So any questions on this result? Last time what we did was nothing got matched. So we got only source data and lookup data is what? Empty. Yeah. Now, partially there is a match, 1 and 4 here. We can see corresponding return values from the lookup table. And unmatched, you will see left table data, which is source data, and lookup data is what? Empty. This is how the lookup table works, lookup transformation works, which is equal to left outer join. Left outer join means matching plus unmatched from left table. So which means in this case, left table is what? Source. That's it. Yeah. Clear, right? We know Ali and Avi.
Yeah. So the source is actually the matched, right? The unmatched. Yeah. Okay. Yes.
Exactly.
That's
Source
right.
means you
So
get all matched ones plus unmatched ones only.
okay. And so how does this differ with the lookup, like the left
Lookup,
outer join and lookup?
yes, exactly. Lookup, sorry, joiner in joiner transformation, left outer join is equal to lookup logic. Okay.
Okay. So I can use this lookup in place of the left outer joiner
We can
transformation.
use it, but yeah, just to answer the question, I'll just add some points. When there is a low volume of data in the lookup, then we can use a lookup. If it is a large volume of data, then we should never think on using what? Lookup. So use join. You got right? I'm just adding one point. There are some more points I'll talk about it. So because joiner would make use of intermediate disk as a storage medium to perform the temporary operations, whereas lookup would try to make use of either cache or in memory to perform lookup operation. That is why when we deal with low volume of data, go with the lookup. When you deal with large volume of data, then go with what? Joiner. If you try to use lookup for large volume of data, then there is a chance to get into what? Thrashing issues or memory issues or abnormal failures, which is very difficult to identify, like where it went wrong. So that is why at the beginning itself, we should understand the volume of data that we deal with. Accordingly, we need to choose what would be the right transformation. Ali?
Right. So you mean that if we use if the lookup is like a dimension table or like a lookup table which is fixed number of rows, not changing, not adding so many rows every time, or just like countries table or cities table.
Yes.
So in that case, we can use. But if it's a transaction table, then where we are going to receive a lot of rows every day
Yeah,
or frequently, then it's not recommended. That's what you're saying, right?
exactly. You are right. Yeah, I'll just add one more point here. Even if you have fixed number of rows, Ali, if the fixed rows has contained what we call large volume of data, example, in that case also, lookup is not preferable. Yeah. But yeah, as you added rightly, right, transaction data, right? So day to day things will keep on getting changed. Yeah. So in that case, we never know the volume of data, right? In that case also, it's better not to use lookup. Better to go with joiner. Ali?
Okay, got
Yeah.
it.
Fixed rows, low volume of data, lookup. Fixed rows, large volume of data, joiner. Transaction rows, large volume of data, joiner. Low volume of data, lookup. Yeah, fine. So, good question. Any other questions from others, Vinu and Abhi? Yeah, start asking any kind of question. It could be simple or complex. Any kind of, see, we're all learning, right? So don't get hesitant to ask questions. Yeah, we're all just learning. Yeah. Now let us talk about
So,
other option.
Nathu, I have a question.
Yes, Vinu.
So, in traditional power center, right? So we have to define the lookup as an active before we import it. Correct?
Mm.
Is there any such criteria also has to be met in IICS?
That's a by default. It would take into consideration.
Okay.
Yeah. So yeah, that's a good thing. Any other questions? See, as I said earlier, active means change of flows. Passive means no change. That's a simple way to define it. Like source, target, passive. Aggregator is active. Example. Yeah. So simple way to understand what is active and passive. Fine. Now
No, I
let
mean,
us
like my question was like in power center,
while
right? Power
selecting
center,
while
you
configuring lookup, we select either passive or what do you call active. I understand
right,
that.
right.
Yeah,
Yeah, yeah.
right. That time, yes. That time we selected either passive or active, but here by default it would take into consideration.
Okay, okay, got it.
Yeah. So now let us go with what lookup condition. I think we talked about in Java also, right? We can add more than one condition. Same concept holds good even in what lookup also. Like for example, we can have multiple keys as multiple columns as what key columns. Example, 7 and C2. Same way as we have it in joiner. So we can have this also. Plus one extra thing we have it here. So we can also use what? Relational operators. Not necessary to be equality. One extra thing we have it here, which we don't have in joiner. Yeah, it is. See, we still have 5 rows. Yeah. The result will be same on this. Yes. So we could able to see. See here, we got only 2 rows got matched. This is not. Because C2, C2, we have added one more condition, right? So both should get matched. In this case, it is not happened for one of the. Okay. Fine. So that's it about adding multiple conditions and see the effect of that conditions over here. So now let's extend this. See, look up how it works. See, it works based on what comparing source with a lookup table, right? Or lookup file, whatever. But how it works based on what? Cache. Yeah. So that's where this particular lookup supports what? Different types of caches, like power center. So we have got what? Static cache. We have got dynamic cache. Then we have got persistent. Yeah. Then we have got shared cache, right? Unshared also we have it. These are the 4 important caches supported by the lookup transformation, right? So that's it. Now, how it works with the static cache? Remember, let us say the lookup has got 100 rows, right? So first when you run, it is going to create a cache and put it in what's on disk space. Yeah. When cache has to be stored somewhere, right? So okay. Now source data would compare with cache and then matches unmatched ones will be transferred to the target. This is how it works. This is what, let's say, run 1. Now let us take run 2. In this case, how it works? Same concept. So it is going to recache irrespective of whether we got a similar records or dissimilar records. It is going to what you call recache. Let us say we got exactly same 100 rows. In that case also, recreation would take place. What is recreation here? Cache recreation. Then storage. Once it is done, rest will be same. Source will compare with the cache. Then you'll get the results in the target. Now third run 3. Let's say we got 200 rows. Yeah. Where we have got some matched, some unmatched. Even in this case also recreation will take place. So which means for all the rows, 200 rows. Yeah. So which means for every run, there is going to be creation overhead for the cache. Yeah. Now the question, if you take second run, where exactly same data, right? We are trying to waste time to create a cache, though we got similar rows. Can we avoid doing it? Answer is yes. So that is where we can go with what? Dynamic cache. Where what it does, first run, it is going to create a cache and then run 2. Let's say here 100 rows. Yeah. So run 2, same 100 rows, let us take. In this case, no recreation could take place because we are trying to create a cache which is already available. It is going to compare whether there is a change with respect to the data. If there is a change, recreation would take place for the records where there is a change, not for all the rows. Yeah. Then test follows, which is comparing source with the lookup, and it does the proper results. Yeah. So that's one thing. Now let us say there are 200 rows. We talked about run 3, 200 rows, where again here also it is going to what you call compare what you call source data and lookup data. Sorry, lookup data earlier pre-created cache against with new ones. In that case, then let's say 100 rows are different. So only for 100 extra rows only recreation will take place. For other ones, no recreation. So in this way, we can avoid recreation of cache where there is already data for it. Now, that's one thing. And what is the problem here? What is the overhead here? Can you guess? The reason is let us there are 100 rows. Yeah. And we got again 100 rows, second run, but only one row got changed. Then what happens? It has to perform comparison. So condition, right? Compare. If it matches, don't do create. If it doesn't, create. That's what it does, right? There is going to be comparison overhead. But if there are what you call less number of changes, dynamic is okay. Many changes out of 100, let's say 99 got changed. Then comparison, see overhead, comparison, comparison plus update. These two overheads. Wherever there is a change, let us say we got multiple tasks, namely task 1 and task 2, where we have got what I call lookup usage. Now the question, can we try to make use of same lookup in multiple tasks? Answer is yes. If yes, how do you do it? That is where we go with what persistent. Meaning what? Cache created in task 1 will be reused in task 2. So which means we created cache once and reuse it in what? Multiple tasks. So we can also say that so cache reuse would take place across n number of tasks. Now the question, can we achieve same thing within a mapping? Let us say we got lookup 1 and also somewhere after transformation and then again lookup 2 where we use similar concept. In that case, can we use this persistent or static or dynamic? Answer is no. Then what would be the answer? Shared cache. Create cache once and use it in multiple transformations within the same mapping, meaning the scope of this particular cache would be within the mapping. As and when the mapping gets over, cache will be cleared off. Remember this. No? That's why I use the term scope. But here the scope is what? Across tasks. Here the scope is within a single task or within a mapping. That's it. This is the high level understanding of how multiple types of caches would work in lookup. Yeah. If you have any questions on this, shoot out now. Yeah, I think you're all there, right? Ali, Windows.
Yeah.
Yes. Fine. So that's it. Now, if you want to configure here, right, you got this. By default, it will just what? Static cache. This is a cache directory. It will be stored in some directory, right? $PM cache dir. So this is similar to Power Center. Yeah. So there will be a cache folder where cache data will be stored. So for example, in Power Center, we got info shared, SRC files, DGT files, cache, temp. We got multiple folders, right? Same way, here also we've got which one? Yes, we've got- so here you can see what multiple folders. One of them is cache. This is exactly similar to Power Center, but only difference here is under data DIS, we got data folder where we can see all. But in Power Center, under info shared, we got multiple folders, which is what I call OS profile. In the sense, administrator, they can create the OS profile. By default, you will have under info shared. But if you want to change, we can also change it as part of in Power Center integration service, right? Go to processes where we can change by editing this environment variable values if you want to change it. Yeah. Same concept.
Narasimha.
Yes.
So in this directory, we will have, let's say the source is a very large volume. So in this directory, we will have the results, including the large volume source data, along with the matched and unmatched rows, right?
No, no, no. This is only for cache. This is intermediate data. But source target we specify as part of the mapping. Only. For example, here we give source some path, right? Which is somewhere outside this location. Yes, sir. Ali. Similarly,
Yeah.
target also we specify our own path. Yeah. So this is different from that location. But if you don't specify, then by default it would use that particular location. So this is our own location. It could be even network location also, like some other data center. You can map a drive and specify that location. Because see, wherever we install this particular IICS, right, we may not expect a large storage in that particular system, but we can have it in some other location. Or else, if you have large data space here, we can also use it. There is nothing wrong on it. Ali?
Yeah. So what I mean to say is the results would be for the matched and unmatched for the time when the mapping is running. So where would the results be stored? The cache,
Intermediate
right?
results. Intermediate.
Yeah.
Yes, intermediate will happen here. So we use it only for intermediate. In the sense, as and when the mapping gets over, right, cache will be cleared off. Nothing will be there now. Now
Yeah.
see, nothing is. Yeah.
Yeah.
This
So
was
so in that case,
intermediate operation.
for,
Yeah.
yeah. So for the intermediate operation, if we have a very large volume source data, so
Mm-hmm.
it, intermediately it will be stored over here, right? With the
Yes.
results of the match.
One second. Yeah, that's a good question. See, here we are caching lookup, not source. This we are caching. So usually lookup will have low volume of data in terms of hundreds of rows, not thousands of rows, not more than, not millions or billions. So which means volume will be very less. Ali?
Can you repeat that?
So you see this cache, right? Cache contains only lookup data, not source data.
Okay.
Got right. Source is very large, but lookup will
Yeah.
contain very low, hundreds of rows or thousands of rows, not more than, not millions, billions. Correct. Ali? So only those rows which is will be part of this cache, not source, only lookup. Yeah.
Ah, okay. I thought it was the results, the intermediate results of the match.
No,
That the
no,
the entire thing will be here. Okay,
no,
got it.
no, only cache. Yeah. So that's why when I talked about concept, right? So first, when we started, right? Yes, here. Let us say, yeah. So we have got 100 rows. It will be cached. Where to where? This. Which location? This location. Right? This is what for lookup only. Whatever we discuss, all types of caches, right? They're all for lookup. So we can also see it practically. If you open it, these lookup options are available. Sorry, cache options are available only for lookup, not for source. You got right, Ali? Can we see
Yeah,
this
I got it.
cache option? Exactly. So yeah, they are not applicable here. Yeah.
Okay.
Okay. So that's a fantastic question. Yeah. Because source data, if you try to cache, yes, it will have a performance. Yeah. Fine. So this normally happens in memory comparisons. Yeah. Memory with a cache. This guy will store in memory. Comparison will take place. Then there is a bit transfer. Similarly, whatever it can fit in memory, only those which will be compared and data would get transferred. That's what happens. Yeah. Fine. So that's it about the connected lookup. Yeah. Now the question, can we have multiple lookups? Yes. We have just focused on only lookup. Let's say this is a customer lookup. Another could be product lookup. Some other could be supplier lookup. Some other could be master lookup, whatever. We can have n number of lookups with one source. One source data can compare with n number of lookups. That is also possible. Yeah? But now we focused on lookup. That's one thing. And we also did not talk about unconnected lookup. We'll talk about it on tomorrow's session and see how unconnected lookup differs from connected lookup. Fine.
Sure, Nasim.
Fine.
Okay.
So that's all for today. Thank you very much, everyone.
Thank you.
Thank you, Nasim.
Yeah, bye.